Alright, so now that we've talked about finding the domain of a rational expression, let's start to move towards solving a rational equation. So one thing that's going to be important to keep straight between this section and the previous one is what an equation is and what an expression is. And remember, equations contain an equal sign and expressions do not. And equations, we are looking to solve for the variable. So we want to end up with whatever the variable is equal to a value or values. Where an expression, all I can do is simplify. So let's first look at solving a polynomial equation with fractions to remind ourselves about the general process for solving an equation that has fractions. So if you remember, when an equation has fractions, we don't really like fractions, so we want to get rid of the fractions. And the way that we do that is to multiply each term in the equation by the LCD. And remember, we can do that now because it's an equation, so we've picked up the properties of equality. So if I look at this polynomial equation, my denominators here are 6, 3, and 1. And you remember when we talked about finding the LCD when we just have numbers that we always start with the largest one. So if I start with 6, I want to know if 3 will divide evenly, and it does. And if 1 will divide evenly, and it does. So my LCD is going to be 6. So now I'm going to multiply each term in the equation by that LCD. If you've ever had me before, you know I call this my nobody likes to be left out property. We can't just pick and choose which one of the terms we want to multiply by 6. We have to multiply every term in the equation by the LCD. So the reason that doing this is nice is because from what we learned earlier, I can cancel so that I'm just left with x squared and my fraction is gone. And the same thing should happen in each term. Now this time I don't have a 6 and a 6, so I have to divide. 3 into 3 is 1. 6 divided by 3 is 2. So I'm left with 2 times 2x. Then we don't have anything to cancel with the third term, so we just multiply. I got negative 6 times 2 is negative 12. And then 6 times 0 is 0. So if we clean this up, I get x squared plus 4x minus 12 equals 0. And you see that I'm left with a quadratic equation. The only way that we've learned to solve that so far is to use the zero factor property. We are equal to 0, so that means I can go ahead and factor the left-hand side. And since a is 1, we need the factors of negative 12 that will add to 4. And I think that that is going to be positive 6 and minus 2. So 6 times negative 2 gives me the negative 12, and positive 6 and negative 2 gives me 4. So then we use the zero factor property and set each one of those factors equal to 0. And then if I solve, I get x equals negative 6, or I get x equals to 2. So we're not going to have any domain issues with this one, because this one is a polynomial equation. When we start looking next at the rational equations, that's when we're going to have to start worrying about the domain. So let's look first at a general strategy that we're going to use for solving these. So first, we're going to want to factor all denominators if they aren't already in lowest terms and determine the domain. Then we're going to find the LCD and multiply both sides of the equation by the LCD. And then we're going to simplify both sides. And then, depending on whether the resulting equation is linear, quadratic, or some higher degree, we're going to solve the equation and then check the possible solutions. And we're going to do two things to check. One, we're going to check it against the domain restrictions. And two, we're going to check in the original equation. And both are necessary here. We have to make sure that a potential solution does not make the denominator equal to 0, because division by 0 is undefined. And we also have to make sure that the potential solution does actually satisfy the original equation, because at times we are going to be multiplying by LCDs that contain variables. So we have to make sure that the manipulations that we have done have not caused me to need to restrict one of the answers. Alright, so let's look at this first question. So both of my denominators are already factored. They're in lowest terms. We can't factor x plus 3 or x minus 1 any further. So the first thing I'm going to work on is the domain. So we just take each unique factor that is in the denominator and set it equal to 0. So I'm going to put x plus 3 equals to 0, x minus 1 equals to 0, and of course if we solve those, we're going to get x equals negative 3 and x equals to 1. Now remember, this is very important, don't forget those are my bad values. So the domain is actually x cannot be negative 3 or 1. So now I'm going to determine the LCD, and we've worked on this stuff before. We did this in the last section. X plus 3 and x minus 1 are two unique factors. They don't have anything in common. So all we can do for the LCD is multiply them together. Now what is different from what we did previously is we're now dealing with a rational equation. We have an equals, so I'm not going to try to make both of these have the same denominator. I'm trying to get rid of the denominators. So we're now going to multiply each side by the LCD. So the LCD is x plus 3 x minus 1. I'm going to multiply the left side of the equation. The LCD is x plus 3x minus 1, and I'm going to multiply the right hand side of the equation. So remember, we've learned that if we have the exact same expression in the numerator and denominator, they can cancel and make 1. So if you want to, you can look at this like it's over 1. So I have an x plus 3 in the numerator and an x plus 3 in the denominator. So those can cancel. And the same thing here. I have an x minus 1 in the numerator and an x minus 1 in the denominator. So those can cancel. So what I'm left with on the left hand side is x times x minus 1. And on the right hand side, I have 1 times x plus 3, which is just x plus 3. So now what we're left with is a much nicer looking equation. We don't have fractions running around, so we just need to start cleaning this up. So I'm going to distribute x times x is x squared, x times negative 1 is negative x, and it's equal to x plus 3. So I see my highest degree is a 2, so this is a quadratic. So the only way we know to solve these so far is to factor and use zero factor property. So of course, to do this, we have to be equal to 0 first. So we're going to need to manipulate the equation. So I'm going to subtract x from both sides. And then subtract 3 from both sides. And we get x squared minus 2x minus 3 equals 0. So now that I'm equal to 0, I can factor and use the zero factor property. So we have a trinomial with a equal to 1. So this one is going to factor into x minus 3, x plus 1. And then we set each one of those factors equal to 0. So I get x equals 3, x equals negative 1. So remember now that these are my potential solutions. So we have to check two things. First, we're going to check against the domain restrictions. And we found out that x cannot be negative 3 or 1. So pay close attention. We got x equals 3 and x equals negative 1. Well, those are the opposite of what we got for the domain restrictions. So we're actually okay as far as the domain. So if that's true, then we'll go to the next step to check in the original equation. So we'll need to check each one. So if x is equal to 3, we're going to plug that into the original. Everywhere there's an x, so we'll get 3 over 3 plus 3. And we want to know if that's equal to 1 over 3 minus 1. So this side is 3 over 6, and this one is 1 over 2. You can use your calculator if you need to. 3 over 6 does reduce to 1 over 2. So the x equals 3 is good. Then we need to also check the x equals -1. So if I plug that into the original, we get -1 over -1 plus 3. And we want to know if that's equal to 1 over -1 minus 1. So we get -1 over 2 equals 1 over -2. And remember, with negatives, it doesn't matter if there's just one, whether it's in the top or the bottom. So these are equivalent. So that means both of my potential solutions are okay as far as the domain, and they both satisfy the original equation. So you can write the answers. You can say x is equal to -1 or 3, or you can use set notation and say that the solutions are -1 and 3. All right. I know this is a lot of work, but I wanted to show you a few different examples so that hopefully you'll feel comfortable working the homework problems and anyone that you come up against. So the strategy stays the same for each one, even though it is a fair amount of work. So for the second one, all of my denominators are already fully factored. They're in lowest terms. So first, I'm going to determine the domain. One nice thing about this is I really only have one unique denominator. So I only need to be worried about x minus 4 equals to 0. So if I solve that, I get x equal to 4. So my domain is x cannot be 4. My LCD, I have the denominator x minus 4 in both of my fractions. So that will be my LCD. And now we're just going to multiply every term in the equation by that LCD. All right, so from the first term, we don't have a denominator, so we can't cancel anything out. So we're just going to, I like to rewrite this in the order that we're accustomed to seeing. In the second one, we do have an x minus 4 and an x minus 4 match that we can cancel. So I'm just left with plus 5. And for the last term, we also have that x minus 4 that we can cancel, and I'm left with x plus 1. So now we just need to clean this up. I'm going to distribute 2 times x, 2 times -4 plus the 5 equals x plus 1. Now notice this time my highest power is a 1. So this equation is linear. It's not quadratic. So we don't need to get equal to 0. We need to get all of our variable terms on one side and all of our constant terms on the other. So I can clean up the left-hand side a little bit first. I have like terms -8 plus 5. So I'm going to make that 2x minus 3 equals the x plus 1. And I generally like to move my variable to the left. So I'm going to subtract x from both sides. So we get x minus 3 equals 1. And then add 3 over. And we get x equal to 4. So this time I only have one potential solution, which is x equal to 4. So my first thing is to check it against the domain, which we found out was x cannot be 4. So this time, the solution that I got is going to fail the domain restriction. This says x cannot be 4, and that's the only potential solution that we got. So that means there is not a value that we can plug into this equation for x and get a valid answer. So that means for this one, the answer is there is no solution.